Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So today, like we all know, we will continue with our bi-weekly meeting. Sponsored bukan sponsored. Organized by Science Chapter UKM. And for this week, will be mathematical debates between Razi and Hakim. And our topics today is tau versus pi. So, please.
Thank you, Vanessa. Okay, I hope everyone can hear my voice. Is it clear? Yes. Yeah, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. My name is Razi. I'm going to talk about the tau and its importance in mathematics versus the pi. That's nothing. No, it's not important. Okay, about tau. Okay, before I start my argument about tau, let me recall first the definition of a circle. Circle is a set of all points in pair from with equidistant from a fixed point, which is the center. So we have a fixed the equidistant radius. So circle like this, then we have radius. So all points here, lies here, will be equidistant from a center. So what I'm going to say that radius is important than diameter. That's the first point. So the circle constant should be defined as circumference over radius instead of diameter. This is what's proposed by Bob Palach in 2001 in his journal Pi is Wrong. He said that circumference over radius is equal to one turn. One turn. Equals to one turn. So in Greek, turn means tornos. We have tau, omicron, rho, mu, o, omicron, and sigma. So that's why we use tau as a symbol to represent one turn, which is numerically equivalent to 2 pi. Okay. So, and next is we know the equation of circle. We use r instead of diameter. So again, I say diameter is not important here, radius is important. That's why the circle constant should be defined as the ratio of circumference to the radius. Equals to one turn equals to tau. So, okay.
Hello everyone, this is Hakim, and I found a point that important that mentioned by Razi, which is tau is near to radius, pi is near to diameter. Let me measure the circumference of circle. I think it's not a perfect circle. Okay, now I want to show you how to measure the circumference of a circle. We know that Razi said the radius. So how to measure the radius? So we need to find the midpoint, the fixed point. And I don't know where is the fixed point in here. We cannot be part, right? But honestly, pi is from the diameter, because we can measure the diameter, we cannot measure the radius. So pi in the definition is the ratio between circumference divided by the diameter. I think we know the pi is known because of pi is sounds like delicious, sounds like pie, chicken pie. I like chicken pie. Let me show you how the Archimedes do about pi. Okay, let's say the circle, and then we put the triangle here. And now we do the polygon hexagon. not a perfect circle. And now this, and this polygon will make the circle, the nearly circle, the approximate circle. And something like this, something like this. And now Archimedes found that the ratio, the polygon, the infinite polygon that form in the circle is 22/7, which is not the exact value of pi. And now how about the outer circle? Let's say circle. And now we put this about the tangent, and then this, and the outer triangle form the ratio 23/71. This means the diameter is important to form the value of pi instead of tau. You know that tau equal to 2 pi. From this equation we know that tau is dependent to pi. And if pi is not known, it's not exist, tau also not exist. So pi, I mentioned here, pi is important than tau because pi is a dependent variable to the tau. And then one more thing. Another fact, which is the outer bound and the inner bound, which is for value pi. But pi is not the exact value. So from the mathematician, we know that pi is equal to 3.141526 and dot dot dot. The dot 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 means the pi means cannot get the exact value. Instead of, you know that 3.142 is not exact. From 8 October 2014, the largest decimal places we can put in pi value is 30.3, not million, 30.3 trillion. And still moving on because of the technologies and the computers. And if we do the tau versus 2 pi, if pi is not exact, tau is 2 times not exact. So I mentioned here, tau will be decrease the precision of pi value. Thank you.
Okay, thank you, Kim. So he mentioned just now tau equals to 2 pi. Tau depends on pi, and pi depends on the diameter, and the diameter depends on its radius. So tau does not depend on pi actually, it depends on radius. And in fact, a circle, a unit circle, we define as a circle with radius equals to 1, not diameter equals to 1. So I still stand by with my argument that radius is much more important. So in that sense, tau is, we should use tau instead of pi. And okay, let's see. We have a circle here. Let's say the center is here. So by using the pi, we have here 0 to pi, 5 over 4, so
2.
5 over 2, 5, 3 pi over 2. See, I get confused easily because this is wrong. This is very, very wrong. Because if you see, if you bake a pie, you actually will be having 2 pi, not 1 pi. Okay?
Yeah.
Yeah, no one's laughing. So we know that tau is approximately equivalent to 2 pi. So we have 0 of tau over 2, tau over 4, sorry, tau over 2, 3 tau over 4. So it's very easy to understand because a quarter of a circle is a quarter of a tau. And you see here, by using pi, a quarter of a circle equals to half of a pi. That's confusing. So, quarter equals to quarter. That's much easier to understand about the circle and the angles. And
Belakang dia Aiman.
no. So, everyone can see, right? Can someone turn the camera? So this is a, okay, we have a circle here. Instead of using tau or pi, I just define this as 0, 1, 1 over 4, 1 over 2, 3 over 4. Very basic one to define the quarter of each of the circle. So we have here, let's say we have one more here, perpendicular, it's by a bisection of 1 over 4 and 0. We have 1 over 8 over here, and we have an angle theta. We have a radius here, and we have a S, which is the length of an arc. So we define theta equals to the length of an arc to its radius. So by seeing here, if this sector define this sector means the 1/8 of a circle, so it also means it is 1/8 of a circumference. Do you understand that?
Yes.
So if this is a quarter of a circle, so the circumference will be the length of an arc from here to here will be a quarter of the total circumference. So we can define the length of an arc, which is a fraction times with the circumference. It can be anything. For instance, in this case, it will be 1 over 8. And over r, it is easily defined as f tau. So we can know that the theta here is actually a fraction of a tau, of a full turn. And if you are using the pi, you will get 2f pi. What is this? What is that? 2f pi, what's that? Or 2 pi f? It's confusing. So I'll say that by using tau, it explains intuitively about the angle. If an angle is, if the length of an arc is a 1 over 8 of a circumference, then the angle will be 1 over 8 of a tau. That's much more easier to understand and to teach children rather than using a 1 whole rotation equals to 2 pi. It's one rotation equals to 1 tau. So proceed with okay.
Some point about the entire revolution of tau radian. If you use tau radian, you do an entire revolution like this, tau. And now 0, we start with 0, and then we get the tau. Tau gets you nowhere. If you measure, you need the unit. Unit shouldn't be the whole thing, and a unit should be a section of it, because if you get pi, you get somewhere in this. Instead of tau, you get nowhere. You get the back of the circle. So it's more nuanced. It's more ridiculous, I think so. Now I will get to the next one. How to derive the formula? Actually, there are formula. Use the single pi. For example, is a equal to pi r squared. You use the pi single pi. And one more thing, the volume of cone. 1 over 3 pi r cubed. The volume of sphere also using the single pi. 4 over 3 pi r cubed. Now, let's talk about the pi. If we replace the pi with the two tau, let's say the cone, volume of cone, it would be tau over 2 r cubed, which is tau over r cubed over 6, which is sounds like ridiculous because we used to memorize the cone, and let's say this cone and this is the cylinder. We know that the cone is 1/3 the cylinder intuitively. So we memorize that 1/3 is the volume of cone. So we easy to memorize 1/3 instead of 1/6. How about the spheres? Spheres 4/3. Spheres. If we replace to the tau over 2, it will get 2/3. 2/3 tau r cubed, which is sounds ridiculously because we have used memorize 4/3 the spheres. And one more thing, if you learn about the complex number, we used to be Euler's identity, which is I pi plus 1. No, I just never see. I minus 1. I pi minus 1. Please use the solitary pi.
Should be plus 1, right?
No, minus 1.
Are you sure?
Oh, yeah, plus 1.
That proves that tau is important.
Tau is related to the pi. Okay, so don't drop it. And then there is more history about pi because many mathematicians do the study of the value of pi, such as Archimedes, such as like Euclid, and also Al-Khwarizmi also study about the pi value. So if you use tau constant, it will kill the how they do it, how they do study about it, because they study for a long time ago. Okay, and this is my point. Thank you. I think pi is more historical between the tau.
Let's see one of the equations written here. This is A equals to pi r squared. Again, so everyone can understand that this equation is basically a quadratic equation because we have power 2. No response?
Okay.
Alright. Okay, so let's recall some physics concept about quadratic equation. So Robert Hooke said that force is proportional to x, the length of elongation or extension or compression. So we have F equals to kx, the proportionality constant. So to find the elastic potential energy, we integrate F with respect to x, and we get kx dx half kx squared. We have a factor of half. If we talk about Galileo Galilei. Okay, he said that about gravitational force, it depends on acceleration. Again, we have the proportionality constant, which is the mass. So if we integrate, we want to find the energy. It's integration of F with respect to x, which is equals to integration of m a dx, and we have here integration of m dv over dt dx. So we can switch actually here dv to dx. So we'll get dx over dt equals to v. So integration of mv dv equals to half mv squared. We get half again. So
Where is your tau?
yeah, okay.
Where is your tau?
So A equals to pi r squared. If we substitute pi with tau over 2, we still get half tau r squared. We have half, half, half. This is the truth. You see, it's a quadratic equation with proportionality constant and half. So, pi is wrong. Wait, I haven't finished. Talk about the Euler's identity. Okay. So Euler's identity says that EI theta equals to cos theta plus I sin theta. So if you plug in pi, you will get this first. -1. Then you do the algebraic. +1 here, +1 here, then you get EI pi plus 1 equals to 0. But if you plug in tau, you get cos tau plus I sin tau. So cos tau is equivalent to 1. And I sin tau equals to 0. So you see the equation, you ask yourself, negative and without negative, which one is more profoundly? Negative, which one is you have negative only. And some may say that EI pi plus 1 equals 0 have 5 most basic numbers, 0, 1, E, I, pi. But I say here, we have here. So we still have 5 unique numbers. So that means, with that being said, again, pi is wrong. It's really, really wrong.
Oh, pi is not wrong.
And we talk about equation. So if we look at the normal distribution, we have, let's say fx, we have 1 over 2 pi sigma exponent negative x over tolak u square over sigma square. Instead of you writing like square root 2 pi, you can actually write 1 over square root tau. It simplifies. And you have more functions like Cauchy integral formula that uses 2 pi, and we have Riemann zeta function that uses 2 pi, and we have Fourier transformation that uses 2 pi. So instead of using 2 pi, you can actually use tau. Tau it simplifies from 2 pi to tau. Okay, please continue your arguments.
Okay, I heard about the circle. Let's do the integration. We know that to get the formula of area of circle, we do the integration 2 by r ini r, and then you do and you get some 5 r square 2 over 2, which is cancelled into pi over 5 r square. Now let's see how the tau affect the integration. Let's say tau r, and then we get tau r square over 2. Over 2 seems like people dislike it. If something like we don't just divide, we just can simplify it, pi r square. So that's the formula. So okay. So okay, let's see this formula. Now 2 pi and tau. We usually use the basic one, not the modified one, such as like this. We used to use the basic formula. So I think pi is the basic of everything. I know said the tau is wrong, but tau is useless. It's not because our tau is equal to 2 pi. Why not we use the 2 pi?
Yeah, it simplifies. Tau
Useless terus.
where you point to pi, you just replace it with tau.
No.
It simplifies.
So, people
Mathematician.
think about the basic, not the modified thing.
And how would you say about simplifying things? Mathematicians like to simplify things.
No, say complex thing.
Like I have much more. So, okay, where do I
And then you
start?
repeat again, tau is equal to 2 pi. See, pi is dependent to tau.
So maybe Hakim has this about the point. Can I write this because I think this is not important.
Yeah, this is important, right?
Okay lah. Remember this. So, Hakim, you missed the point about area of a regular polygon. Would you like to mention for the area of a regular polygon?
What? What is this? You explain it because this.
Oh, because I can tell you that again, tau simplifying things. So before this, area of a regular polygon is defined as n sine pi over n cos pi over n, where n is this number of sides of a polygon or n-gon. So, but we know that sine theta cos theta equals to half sine 2 theta. Is that right? You agree with this? So we plug in back, we have this one equals to n over 2 sine 2 pi over n, which is equivalent to n over 2 sine tau over n. So you see for yourself which equation is much simpler. Are you going to use this part or using tau? Thank you. So, and actually from here, since n is the number of sides, and Hakim has mentioned before that if number of sides, if the Archimedes draw the hexagon and everything, and it's the pi approximates to 22/7, and if we use the L'Hopital's rule, we can find the area of a regular polygon with unit radius, which is 1. We can find that area of a circle again is equals to half tau, since r is 1. So do you want me to show the L'Hopital's rule? I think everyone knows, right? L'Hopital's rule. Right? Okay. So as I mentioned earlier, as n become larger, the number of sides become larger, it will transform itself into circle. So we have, let's say a equals to the limit of n over 3 for the function n over 2 sine tau over n. So we can use the L'Hopital rule in which you can differentiate the numerator and the denominator. So I write it like this first. So these two equations are the same. So if you do the differentiation, you'll get half. You differentiate this part and differentiate this part, not using the quotient rule. We just use the normal differentiation. So differentiate sine, will get cos tau over n. Then you get differentiation of this, you get negative tau over n squared. And here you get negative 1 over n squared. So you can cancel out this part and this part to get cos tau over n tau. Negative and negative cancel each other. And again, when n approaching infinity, tau over n will be approaching to 0. So cosine of 0 equals to 1. So you get half tau, which is the area of a unit circle in terms of tau. So, as for conclusion, I'll say that tau wins the battle. That's all from me. Thank you for listening to our talk.
I come to my conclusion. If you notice that Razi always write the pi first instead of tau. Why pi first? See, you write the pi first. Which means pi is more important than tau. Instead of me, I write pi first instead of tau. So you see that the tau is dependent to the pi. And so okay, you know that like I want to repeat this point. Archimedes, Fibonacci, Al-Khwarizmi also used the pi as their study of mathematics. So if we want to use the tau in kill the pi, if it is something like we not appreciate their works about the study of mathematics. Instead of that, pi is important in the other fields like such as like physics, cosmology, mechanics, fractal, statistics, electromagnetic, and so on. If we use tau instead of pi, it sounds like we not appreciate the mathematician works about pi. And some point I want to do is, I think tau is not wrong because it's not being used. It's not being used, and pi is good because pi is perfectly serviceable. That's all my conclusion.
I'd like to say something. Can I continue? Just
No.
Because you said that I always write pi, then I transform it into tau. Because yes, it is true that pi comes first. Because this tau, this is proposed in 2001. I didn't say pi is wrong, even though Bob Palai said pi is wrong. I'm just repeating what he said. I didn't say that pi is wrong, but tau is not wrong either. And I just want to say that tau simplifies equation. It simplifies equations. And since the pi has existed years, thousands of years, so I have to start from there to show that it will simplify to something else if we use tau. It doesn't mean that tau is wrong because tau is invented. No, we're using tau in 2001. How can I use tau first, then convert to pi? I have to use pi first, then convert to tau. I'm not angry, I'm just scolding you. Okay, so we're good.
Okay.
Yeah. We're good. Okay. So tau or pi, whatever we need. Okay, thank you.
Duduk dulu. Okay, do you have any questions about tau or pi? Oh yes, okay.
What is the value of tau? At least we know the value of pi is 3.1 for something. Then what is the value of tau?
So you just have to multiply with 2. That's so simple, 6.28 something.
Yes.
He said the 3.14159 . So I said 6.28 . It's acceptable. Any other questions?
Tau is just 2 pi. But haven't you ever wondered, because you always see 2 pi in your formulas and calculation, why haven't someone invented a symbol to just replace this 2 pi? I certainly thought about it a lot because there was a lot of 2 pi's in the formulas. Or why not simplify? Yeah? Oh, but I'm not on Tau's side. I have to be neutral. And tau does have a lot of historical significance, and that's one of the way people estimated it. In fact, Pythagoras estimated it a long time ago and got to quite accurate, tak ingat lah, quite a lot of significant numbers.
From 2009, 1.3 trillion decimal
from 2009, 1.3 trillion decimal places, and people are still using it for randomizing things because the numbers are so random. So some random number generators use pi to get random numbers, and it's an irrational number. So it will never end. Yeah. So you can always trust pi and tau to be irrational and never end. So any more questions? Oh, Prof. Salmi, thank you very much for coming. And hopefully we'll be having you to talk to us soon, probably next month in October. Yes. Oh, and I would like to thank the speakers for their effort, and also would like to encourage anyone else to come and have a debate or give a talk or do any sort of mathematical performance in front here, and you will at least get some sort of Siam merchandise, and they have like really cool t-shirts there on which they will be able to keep for the rest of their lives. Buka Razik, tunjuk belakang. It has a math intersection cool. It's not equal to empty set. And if you don't understand that, you really need to go to your classes. Yes, so, next 2 weeks, we're hoping to have the next session. We're not sure who the speaker is yet because of the inavailability of people. And if you have any more questions about tau versus pi and the actual debate, it is actually happening among mathematicians, and you can, if you don't believe me, you can always Google it and find it on YouTube. They have an actual debate on YouTube about tau versus pi, and the actual papers, like what Razik said. What was the title?
Pi is wrong.
Pi is wrong, says the paper. So if you don't believe me that this is an actual mathematical debate, although nobody really hates each other. I mean, pi is tau divided by half, and tau is 2 pi. But we really want mathematics to be easier for people to understand, and therefore that's why we propose tau, because it's easier. Not we mathematicians propose tau because it's easy to explain to people. So any more questions? Last question before we go on, or maybe you have any points in support of pi or tau, or maybe you feel that this is insufficient and you want more. Next session we'll continue the debate. Alright, if not, then if anyone wants to give a presentation, let me know. Anyone has an interesting topic, and again, a big hand to our mathematical debaters. Thank you.